So NumPy and Pandas are two of the most important libraries you will use for data science. Um, and we're going to start with NumPy, which is the more difficult one. I've done that for a couple of reasons. Pandas, I think most of you will probably be all right with, at least get the gist of it quite quickly, because Pandas is a bit like kind of a supercharged Excel in Python. That's you'll be able to relate back to it. NumPy is a bit more weird. Now I'm flagging this up now because it is a bit more complicated, and I flagged that up deliberately because I don't want you sat there thinking I'm completely lost. I have no idea what Dan is talking about, and feeling as though you're somehow sort of falling behind. There may be others. In fact, I suspect many of you will not grasp all of NumPy at this stage. I would also recount the story. I remember my colleague Tom told me he used to teach NumPy as part of an undergrad course to people who were well used to programming, and one student once came up to him and said about NumPy, "This is too much. It is too much." And they were visibly distressed by NumPy. So I'm flagging that up now. I am hoping that you won't find this too much, but you may find it a little bit more challenging than some of the things we've covered so far. So just be aware of that. But I've tried to make this as friendly an introduction to NumPy as possible. Much as with Pandas later, I'm only going to skim the surface of the things you can do with NumPy. You will see lots more examples of stuff you can do, really neat stuff you can do with NumPy throughout the course. But even that will only skim the surface, and there's so much more out there. We can't possibly teach you all of NumPy, much as we can't possibly teach you all of Python. But hopefully this will give you a bit of grounding in some of the basics, and will also show you why this slightly complicated thing is so worthwhile. Okay, so NumPy is an abbreviation, stands for Numerical Python, and it's really, really important for scientific computing, and it provides a lot of features that are fundamental for scientific computing. One of the major ones is it provides the ability to work with large multi-dimensional arrays hugely more efficiently than if you don't use them. Okay, now the reason for this is that NumPy arrays are written in a language called C, which some of you may have perhaps used or at least heard of. I mentioned a few weeks ago Python is a lovely language. It is not very efficient. Python is very friendly, but that friendliness comes at a cost, that it is slower than some languages that are a bit closer to the metal, like C. NumPy arrays are written in pure C code, which makes them hugely more efficient. And I will show you later how much faster they are. And for the kind of examples you're going to be using in the exercises, you'll kind of think, well, what's the point? It doesn't seem much benefit. When you get onto stuff like machine learning, it becomes almost essential because you're suddenly dealing with huge arrays. You're not dealing with a little list with 5 elements in it with 5 numbers. That would be overkill for to use NumPy for that. You'll be using things with thousands, hundreds of thousands of entries spanning hundreds of dimensions. So NumPy does become quite important, and particularly for the machine learning stuff, the natural language processing stuff, that will all use NumPy in some way. So NumPy comes with a lot of distributions, scientific distributions of Python. Anaconda is one such example. So most of you got the Anaconda distribution. It comes pre-installed with that. And so in order to work with NumPy in our code, all we have to do is import it. And this is one of the packages that has a conventional alias. So I mentioned there are a few of these where you are convention dictates that you don't just import NumPy, you import NumPy under an alias. So we say import NumPy as, and the alias we use is NP. Now, as I mentioned before, that alias can be anything you like. You could call it pasty or tea cake, if you like. You can tell it's getting close to lunch. But you'll be frowned upon most severely by members of the Python community if you do so. You should always type the words import numpy as np, and you should therefore, henceforth in your code, refer to numpy as np. Okay, do not break the golden rule of not referring to numpy as np. So just flagging that up. Pandas has got a similar one, which we'll talk about later. So the main object in NumPy is what's known as a multi-dimensional array. And I keep saying the words multi-dimensional array, and you may be sat there thinking, what on earth are you talking about, Dan? What the hell is a multi-dimensional array? Okay, well, let's break that down a little bit more simply, and then we'll break it down a bit more simply again. So let's consider what a one-dimensional array looks like. You've already been working with these. You've been working with lists. Okay, so a simple list is an example of a one-dimensional array. It is an array with one dimension of numbers. We can also have things called two-dimensional arrays, which are arrays within arrays. And you've already seen a little example of that as well, which is where we've got lists within lists. So there are two dimensions of array there. There's the dimension which holds the kind of three outer lists in this example, and the dimension which holds the elements within each of those lists. Okay. We can also, by extension, have three-dimensional arrays, which is an array within an array within an array, and that's a list of lists, basically. And within NumPy, arrays are referred to as axes. So you'll hear the term axes in NumPy, and it basically means the dimensions within a NumPy array. Now, that probably, again, still feels a bit abstract. So let's try and pin this back to something a bit more real world that we can get our heads around. Now, the examples I'm going to give you here are not the best use of NumPy. This is how you wouldn't generally use NumPy to store this kind of information, but as a way of trying to understand a multi-dimensional array, hopefully they're helpful. Okay, so let's think about some practical examples. If we had a list of ages, that's an example of a one-dimensional array. Okay, it's a simple list with some ages. That's a one-dimensional array. If we had a list of ages for each person in a number of groups, that would be an example of a two-dimensional array. Our two dimensions would be individuals and groups. Okay, so we might have three groups, and each group has 5 people in it, and each of those people has a different age. That's a two-dimensional array. Then we might have a list of ages for each individual within each group, within each department. Okay, and that would be an example of a three-dimensional array, because we've got individual ages as one dimension, we've got groups as another dimension, and we've got departments as another dimension. So in order to find any individual, we'd have to know their individual place within that group, and also which department. Which group, individual place within a group, which group they belong to, and in which department. Okay, that's a three-dimensional array. And hopefully that's a bit more easy to understand what a multi-dimensional array might look like, and therefore what a 4-dimensional array, or a 10-dimensional array, or a 100-dimensional array might look like. A 4-dimensional array might be, you know, you've got a list of organisations, each of those have departments, each of those have groups, and each of those have individuals with ages, etc. So that would be an example of a 4-dimensional array. Now, in machine learning, multi-dimensional arrays are very common, because in machine learning, as we'll come on to when we get to module 4, we're basically trying to predict or classify some sort of outcome based on a series of input values, and they're referred to as features. Again, we'll talk more about that in machine learning. But it's things like, you know, can we predict whether the patient has this condition based on their age, their number of admissions, and all sorts. And you can have hundreds of these things, sometimes even thousands of these things, okay? And each one you have adds another dimension to your array. So you can imagine, if you only had a machine learning problem that had 3 dimensions, you could just about get your head around that, a list of lists. It would be messy, but you could get your head around it. Trying to get your head around a list of lists, that's just not going to happen. We cannot, as human beings, envisage that. But if you think back to this simple example of Basically, you're just adding another dimension of information. It's okay. Well, they might be in a group, which is in a department, which is in an organisation, which is in a subdivision of a company, or whatever. Okay, so that's effectively what you're doing when you create a multi-dimensional array. And because we end up with these huge multi-dimensional arrays when we're dealing with things like machine learning, we have to have a solution that allows us to work with those things more easily and efficiently. And NumPy gives us that ability, and it does that via something known as a NumPy array. And a NumPy array is an array that can be hugely multidimensional and retain its efficiency, and can perform extremely rapid calculations on these huge multidimensional arrays. So that's why we use them. And you'll see more of an example after lunch about why they're so useful.